Nuclear clock, 100,000 times more accurate than atomic and may reveal the secrets of the universe. The new clock can contribute to revealing the secrets of the universe. This significant development comes from the University of Colorado Boulder. Researchers at the Gila Research Institute at the University of Colorado Boulder in the United States were able to identify the components required to build the most accurate clock ever, which means a very important first step that was greatly welcomed by physics circles around the world. In a study published on September 5 in the journal Nature, physicists identified the frequency of light required to excite the nucleus of the element thorium-229 to move to a higher energy level. Physicists expect that this innovation will contribute to conducting more accurate research related to particle physics and discovering the depths of dark matter. Timekeeping throughout history. Clocks have evolved over time several times. The ancient Egyptians, Greeks, and Romans used very simple methods to tell the time. These methods included sundials, which are columns fixed in the ground whose shadow changes throughout the day, followed by advanced water clocks. A water clock consists of one or two vessels filled with water, each with a hole through which water passes. The passage of a quantity of water represents the passage of time. In the 17th century, specifically in early 1657, the scientist Christian Huygens developed the first model of the pendulum clock. It consists of a weight that moves right and left attached to a metal gear. The movement of the gear means the passage of 1 second. Later, the mechanical clock appeared, and it works in the same way as the pendulum clock, except that scientists replaced the long pendulum with a small metal coil capable of contracting and relaxing, moving the gear. Humans' ability to build the most accurate watches has evolved over time. Finally, the Quartz Watch appeared, a special material that produces electricity when exposed to pressure, and vibrates when we supply it with electricity. The watch works when the battery emits electricity, causing the quartz material to vibrate, which emits electrical pulses that transistors can measure. Because the accuracy of this watch may be affected by many factors, scientists turned to developing the atomic clock, similar in concept to the Quartz Watch. Instead of quartz, scientists use the element cesium, and instead of the battery as a source of energy, there is a source of microwave radiation, which is the radiation used to heat food in household microwave devices. Scientists determine the amount of a second not through vibrations as was the case before, but by monitoring the transition of electrons orbiting the cesium nucleus from a lower energy level to a higher one. But the nuclear clock works differently. You see, any element consists of an atom, and inside the nucleus are protons and neutrons. So when the nucleus is exposed to a certain amount of energy, these protons and neutrons move to a different energy state, just like when we eat sugar and derive the energy that we use to move throughout the day. Xuankun Zhang, the lead researcher of the study, pointed out that the nuclear clock relies on changing the energy state of the protons and neutrons inside the nucleus, instead of the electrons moving to the higher energy orbit. Chang explains that the main difference between the nuclear and atomic clocks should not be reduced to accuracy. As obtaining a highly accurate nuclear clock requires years of experiments, then this clock will outperform its atomic counterpart by stages. On the other hand, the researcher explained the most important features of the new nuclear clock, the first of which is its reliance on molecules and interactions different from those specific to how the atomic clock works. And the two clocks can be used together in physics research in order to obtain accurate results. Chang believes that the nuclear and atomic clocks will help test the validity of physical constants that scientists have long relied on, such as the speed of light and the gravitational constant. And this will help answer the question about these constants. Are they really constant? Also, the higher stability rate of the nuclear clock compared to all previously made clocks, as a result of it not being affected by external environmental factors, such as magnetic fields, means increasing its effectiveness. The clock's core can be placed in solid bodies, which means it can be used outside research laboratories without any problems. Understanding the universe better. Mustafa Bahran, a visiting professor in the Department of Physics at Carleton University in Canada, to evaluate the effectiveness of the new clock, explained that the atomic clock derives its energy from a visible light laser, while the nuclear clock derives its energy from a higher energy and frequency ultraviolet laser. The atomic clock is wrong by 1 second every billion seconds, while the nuclear clock that is under development is wrong by the same rate every 100,000 billion seconds, Bahran added. Bahran does not believe that this new technology for measuring time will directly contribute to human life, but it will certainly contribute to a deeper understanding of the universe around us. Some physicists suggest that dark matter is a substance with a very light mass that slightly affects some physical constants, such as the strength of the magnetic force. The nuclear clock, and before it the atomic clock, helps to monitor these slight changes. Chang agrees with this view, as dark energy, according to his definition, has been